Hello everyone. Let us now discuss how can we solve this problem. Smallest subarrays with maximum bitwise OR. So here we are given with simply the description says that we are given with a nums array where this array is having some numbers. Now for every element I need I need the size of the smallest subarray subarray with max or with maximum or value. So for every element I need to get the smallest subarray starting at that index and I will be having a max or. So it is nothing but getting a subarray with max or starting at that index every time. Now let us see at an example, but instead of solving it in a manual or given in the description way, let us take 1, 0, 2, 1, 3. Now, what is the condition that or will get max, right? So if I have something like 5 and 3, let us see I have 5 can be represented as 101 and 3 as 011. Now 1 and 1 or 1 will give us 1 or 0 give us 1 or 0 will give us 1. Now let us look at an example where we have 8 and 1. 8 will be having 8 or 1. I am doing, sorry, I am doing OR operation, right? So 8 will be represented as 1 0 0 0. Now 1 can be represented as 1 0 0 0, right? So 1 or 0 will give us 1. 1 or 0 will give us 1. Everything will give us 0. So if I have a 1, then I can get a set bit, right? That's what the intuition says. So if I get a set bit, then I get max or. So what I want is a 1 at the current element or another element, right? But here I need a subarray which is starting at 3 and which is starting at 1, which is starting at 2, at 0, at 1. So let me give the indices for this: 0, 1, 2, 3, 4. Now I'm writing how does this 1 will be represented in bit representation. 0 0 1, right? In a 32-bit representation, I am representing it as this: 0 0 1. Now 0 as 0, wait a second, 0 0 0 for 2, 0 1 0, 0 0 1 for 3, 0 1 1. Now let us look at 3 as I need the max or I'm starting with this 1 and 1. So everything I'm initializing the answer as 1. But wait, now I have 1 1. For 1, do I need another 1 to get a max or? Let us look at how this or works. So in or operation, 0 and 0 will result in 0, 0 and 1 will result in 1, 1 and 0 will result in 1, 1 and 1 will result in 1. So the or will be having the will behave like this: if any one is having a 1, then it will result in 1. So this position is having 1, so no need to search for another one. This position is having 1, no need to search for another position. This position is having 0, I need to search for 1 after this. Why I'm saying that after this index I need that index which is having a set bit at this position. Why? Because if I got that, then that minus this index plus 1 will be the maximum size. But wait a second, you might be confused at this second, but here I am saying the answer is 1 because 0 is doesn't, at this position I didn't get any index which is having a set bit at that position. Now let us go to this index. I am going from right to left. If you see, right to left. Now this one is having a set bit at position 0. At this position, just let us say that this position is having a set bit at here. Now here in this I have a 0, right? So for this 0 to get the max or I need a 1 at this position, right? So what is the nearest index where I got a set bit at this position, which is just 4. I am talking about the index 4 minus 3. As I said, the max first one will be 1. As I said, answers will be initialized with 1. 1 comma 4 minus 3 plus 1. Why? Because I am taking these two numbers for the sub array 1 comma 3 as a sub array, right? So I am doing 4 minus 3 plus 1, which would give me 2, right? So from this the maximum will be 2, right? So I am just getting the maximum. Now you might be confused that where when they are asking for the minimum subarray, why are you getting the maximum every time? I'll tell you. So I said nearest index which has a set bit at that position, right? So when I say nearest index, that means I get a max or and also the minimum subarray every time. So here the answer will be, so let me delete all this. So here the answer will be 2, right? So for this 0, for now I just looked at this 0 and said that the answer might be 2. Now what about this 0? Do I have any index after this index which is having a set bit at this position? No. Why? Because all those after that are zeros, right? Only one index and it is having 0 at that position. So for now the answer, and also for the last, also the final answer will be 2 for this index. Now let us go with this index 0. Here, you might say that you might be confused the previous one, that max, you are taking the max, or why we are not taking the minimum. If you see, for this position, I have 0. I need to get 1. I need to get a set bit at that position. So you might look at here and also here. But I said nearest index which has, I'm writing again, which has a set bit at the position where I am looking at. I will look from 0 to 32 as it is an integer range. So I am just deleting it. So nearest index which has a set bit at the position which we are looking at. So nearest is this, which is 3, but initially it will be 1. Now 3 minus 2 plus 1, which will give us 3 minus 2 is 1, right? 1 plus 1 is 2. So the maximum from those is 2. Now let's go to the next position, which is 1. If you see, if I have a 1, should I look at other 1? You might say that here I have a 1, but wait, or it is or. I need not to look at a position or at any index which is having 1 if I have a 1 at that position, because here it will always give a 1 every time. If I have 1 for even one time, I would get 1 as the result. So just skip this one. I will be doing every time and just skipping the one. Now let us get to this 0. 0 is having any one after that? No. Now let's go to this 0. Now, initially it is 1. Now for this 0, the next or the nearest set bit position, set bit index which have a set bit at that position is 3. 3 minus 1 plus 1, which will give us 3 as the max. So 3 might be the answer. I didn't go to the next positions. So let us wait. Now I have to go here 0 and here it is 1. Now 1 is at it is a set bit at index 2. 2 minus 1 plus 1 is giving me 2. From this 3 comma 2, the maximum is 3 itself. So we don't consider, we don't update. So 3 will be our answer. Now you must ask, as it is saying for this 0, everything after that is not having a set bit at that position. So let's go to the next index. Let us initialize with 1. As I said, for this one, no need. For this 0, I need a 1 at that position. So go here. What it is saying, index 2 is having a set bit at that position which we are looking at. 2 minus 0 plus 1, which will give us 3. So the answer here will be 3. I think here you might be having the same thing, double three, double two, one. So what I just did, so I think you might understood, but how can you write the code? Let us write that with the algorithm. Let us initialize vector of int and name it as rightmost, and let it be 32 positions with minus 1. As here I'll be having 32 bits. Now what I'll do is I'll iterate from for I int I is equal to n minus 1, and I go till I is greater than or equal to 0, and I am going from backward. Now what I'll do is, just if I have a set bit, I am writing here. I think I say you, or I want you to write the code for this part without looking the code which is given in the description. So what we need to do is, if the current num is having a set bit at POS, that means at position, I am talking about position, then make right most of position is equal to where I am index. That's what I stored. You might say that here what it will be. Let me tell you, 0, 1, 2, 3, 4, and so on till 31, right? So at index 3, sorry, index 4, I have 1 and 1. So here I will store 4 and 4, remaining will be minus 1. Why I am doing it? So I am not taking the position. If you see, I need the index. So here it is 1, so to skip it. So here it is 0. So look at this 1. I got 4. That's how 4 minus 3 plus 1, which would give me 4 minus 3 is 1 plus 1, which is 2. So that's what came here. So position that make rightmost of position is equal to I. Now for this index, get the positions where it is 0. Then then let let us initialize max is equal to 1. That's what I said. The max will be 1. I said the answer will be initialized from from 1. So then let max is equal max e. Let's take that as max e. So max of max e, comma, the position where I got. Now for this index, get the position where it is 0, and get the index. Now how do I write it? Index minus I plus 1. Only if it is 0, and I get the position where it is not, then let max e is equal to max of max e, comma, index minus I plus 1. So it will be something like here, only if position right most of position is not equal to minus 1. So if I have to write this as in a code, let me tell you that stop here itself, and here what I'll do after this, answer of I is equal to maxi after getting through every index from 0 to 31 after all positions. So after that I'll return the answer at the end. So stop here and try solving it, and if you don't get, so stop for some minutes or some even for half an hour, and then get back to this video. So let me explain you how does the code looks like. Now, as I said, answer will be initialized and rightmost will be initialized. So I am going from right to the left. Now, this is what I said you to write. So I am going from 0 to 32. Here also 0 to 32. As I said, I go from 0 to 32. Nothing but here less than or is equal to 31, or you can also write less than 32. No, nothing. No problem, right? Now if nums of I right shift by bit and 1, if it is true, that means if it is 1, rightmost of bit is equal to I, that means the index is initialized to the position, the bit position, right? So in bit is equal to 0, and every time bit is less than 32, and if rightmost of bit is not equal to -1, max reach is equal to max of max reach and rightmost of bit. So this is how you solve this problem, and answer is equal to max reach minus I plus 1. Now after that I'll be returning the answer at the end. So this is how you solve this problem, and if you have any doubts, please do comment in the comment section, and thanks for watching this video.